Pretty mind-bending. Einstein-Rosen bridges.
Or as most people know them, wormholes.
Exactly. Those theoretical tunnels through space-time. We'll be exploring what we know about them, what's still a mystery, and even how scientists are trying to find them out there in the vastness of space.
And what's really fascinating is that wormholes aren't just a science fiction idea.
Right. They come from Einstein's theory of general relativity, which basically revolutionized our understanding of gravity.
Yeah.
So, just to recap for our listeners, Einstein said that massive objects actually warp the fabric of space-time, and that warping is what we experience as gravity. So, are wormholes like extreme versions of that warping?
That's actually a pretty good way to think about it. Imagine like a bowling ball on a trampoline. It makes a dip in the fabric, right? Now imagine an object so dense that it actually creates a tunnel right through the trampoline. That's kind of the basic idea behind a wormhole.
A shortcut connecting two distant points in space-time. So, like, instead of traveling the long way around the universe, you could just take a shortcut through a wormhole.
Yeah, exactly.
But hold on, I've heard that going through a wormhole would be, well, not exactly a pleasant experience.
That's true. The original wormhole model, the one proposed by Einstein and Rosen back in 1935, is what we call non-traversable.
Mm.
These wormholes are basically unstable, and they would probably collapse before anything could actually pass through.
So it'd be like trying to walk across a bridge that's constantly crumbling beneath your feet.
Yeah, pretty much.
Yikes, not exactly the smooth cosmic ride I was hoping for. But what about those traversable wormholes we see in science fiction? Is there any actual scientific basis for those?
Well, that's where things get really interesting. Physicist Kip Thorne, he proposed that for a wormhole to be traversable, it would need something called exotic matter.
Exotic matter.
Yeah, basically it would need exotic matter to keep the throat of the wormhole open and stable. Kind of like a scaffolding, holding the tunnel open so you can pass through safely.
Okay, exotic matter. But is that
Ah.
something we've actually observed? Or is it purely theoretical?
It's still very much in the realm of theory. Exotic matter would have some pretty wild properties, like negative energy density. Imagine a substance that pushes outwards instead of being pulled inwards by gravity.
It's like anti-gravity almost.
Exactly.
Wow, that is mind-bending.
It is. But if it exists, it could be the key to making traversable wormholes a reality.
So we've got these cosmic shortcuts, potentially connecting distant parts of the universe, maybe even different universes. It's a lot to wrap your head around.
And we're just getting started. The implications of wormholes go far beyond just space travel.
Oh yeah, in what ways?
Well, they could totally revolutionize our understanding of the universe itself, from its shape and structure to the very nature of information.
Okay, you've got me hooked. What kind of revolutionary implications are we talking about? Tell me more.
Well, imagine a universe with wormholes crisscrossing it, creating shortcuts between distant regions. That would fundamentally alter our understanding of the universe's structure, and the distances between cosmic objects.
It'd be like discovering a network of secret tunnels beneath a familiar city.
Exactly. Wormholes could basically reshape our cosmic map, revealing hidden connections and pathways that we never knew existed.
That's a pretty wild thought. So instead of the universe being this vast, sprawling expanse, it could be more interconnected than we ever imagined.
Exactly. And it makes you wonder about all those multiverse theories, right?
Right. Could wormholes be the key to accessing those other universes?
Absolutely. Wormholes could potentially act as gateways between parallel universes.
Yeah.
Turning the multiverse from just a philosophical concept into a physical reality.
Wow. So we've got cosmic tunnels linking different parts of the universe, maybe even different realities. What else?
Well, this brings up an interesting question. What role do wormholes play in the grand scheme of things? Could they be connected to some of the biggest mysteries in cosmology, like dark matter?
Ooh, dark matter. I'm all ears. Tell me more about this connection.
So dark matter makes up a significant portion of the universe's mass, but we can't see it directly, or interact with it in the usual ways. Some physicists believe that dark matter could be composed of particles that interact with, get this, microscopic wormholes.
Wait, really? Tiny wormholes?
Yeah, potentially explaining why it's been so difficult to detect.
So these tiny wormholes could be like hidden pathways for dark matter to travel through.
That's the idea. It's a pretty bold theory, but it offers a fascinating new perspective on one of the biggest mysteries in astrophysics.
Wow, this is already a lot to digest. Wormholes are connected to gravity, potentially to dark matter, and maybe even to other universes. It's incredible how one concept can lead to so many mind-blowing possibilities. What else is there to uncover about wormholes?
Well, we've only just scratched the surface of their potential. We haven't even touched on the fascinating relationship between wormholes and information itself, and that takes us into the mind-bending realm of quantum mechanics.
Okay, now I'm really intrigued. What does information have to do with cosmic tunnels? This deep dive is full of surprises.
You're in for a treat. It all starts with a problem that has puzzled physicists for decades.
Hmm.
The black hole information paradox. So before we went to whatever you call it when you're listening to this.
A break.
Yeah, a break. Before the break, we were talking about the black hole information paradox. You know, this paradox, it comes from a really basic principle in physics. Information can't be destroyed.
Right, right.
But when something falls into a black hole, it basically vanishes.
Yeah.
Right? And that includes all the information it carries, which is a huge problem for our understanding of physics, you know, how the universe works.
So how could wormholes fix this? Do they somehow, like, rescue the information that falls into a black hole?
That's one of the really fascinating possibilities. Some theories suggest that the information doesn't actually disappear inside the black hole.
Okay.
It travels through a wormhole instead and pops out somewhere else in the universe.
Oh, wow.
It's like a cosmic escape route for information, you know?
So it's like, instead of being information destroyers, black holes are actually information gateways.
It's a cool thought, right?
Yeah.
And it shows how everything's connected in physics. We're talking about black holes and wormholes and even the idea of information itself. And it gets even more interesting when we think about the holographic principle.
The holographic principle, we talked about that a little earlier.
Yeah.
It's about information being encoded on boundaries, right?
Exactly. The holographic principle says that all the information within a region of space can be encoded on its boundary, like a 3D image being projected from a 2D surface.
Oh, I see. Okay.
And if we apply this to wormholes, some physicists think that the information going through a wormhole would be encoded on its event horizon,
And it's event horizon.
the boundary beyond which nothing can escape.
So the event horizon is like a cosmic memory card, storing information about everything that goes through the wormhole.
It's a pretty cool way to think about it. The holographic principle suggests a deep connection between information, space-time, and the very structure of wormholes.
This is really making me rethink some things about how the universe works. But we've talked a lot about theory, so what about actually finding wormholes? What are scientists doing to try and actually locate them?
That's a great question. Directly observing them is tough, but scientists are exploring some cool ways to indirectly detect them. One way is to study gravitational waves.
Right, those ripples in space-time. I remember we talked about how scientists detected gravitational waves from colliding black holes.
Yeah.
Could wormholes create similar signals?
That's what we're hoping. The theoretical model suggests that the gravitational waves from a wormhole would be unique, different from those produced by black holes or other cosmic events.
So they'd have like a different sound?
Yeah, like a cosmic melody, you know, one that says, hey, there's a wormhole right here.
So scientists are listening for these like tiny whispers in the symphony of gravitational waves that are constantly washing over Earth.
Exactly.
Good.
And with more sensitive detectors like LIGO and Virgo, we're getting better and better at hearing them. Who knows what we'll find as we keep listening.
So gravitational waves are one way. What other things are scientists looking at?
Another approach is to look for weird behavior in the motion of stars and gas clouds near black holes.
Okay.
Wormholes would have their own gravity, which could affect the orbits of these objects in a way that's different from just a black hole.
So if we see a star like wobbling around a black hole in a weird way,
Yeah, that could be a sign that there's a wormhole messing with its movements.
like a cosmic ballet.
Huh? I like that. We're basically looking for subtle deviations from the predictions of general relativity, and those deviations could hint at the presence of something exotic, like a wormhole.
It's like we're cosmic detectives, you know, piecing together clues from the movements of stars to find these hidden structures in the universe.
I like that analogy.
And it reminds me of how early astronomers figured out that planets were orbiting the sun just from their movements across the sky. And now we're looking for similar clues, but on a much grander scale.
Exactly. And speaking of looking back in time, there's another cool possibility, one that takes us back to the very beginning of the universe, the cosmic microwave background radiation.
The faint afterglow of the Big Bang, we talked about that earlier.
Yeah, and how it might hold clues about primordial black holes.
Right, right.
Well, it could also hold clues about primordial wormholes, ones that formed in the early universe.
So we could be looking back billions of years and see echoes of these ancient wormholes. Wow.
It's a pretty amazing thought, right? It really highlights how everything's connected in the universe, from the smallest particles to the largest structures, even across time. What we see today might carry traces of events that happened billions of years ago.
Wow. So we've got these potential wormholes connecting different parts of the universe, maybe even different universes, and they could play a role in some of the biggest mysteries in physics. It's almost too much to think about. But there's one question I have to ask.
Go ahead.
Well, we've been talking about wormholes as these passive things, shortcuts through space-time.
Right.
But could we, and this is where I might be getting a little too sci-fi here, could we actually create a wormhole?
Now you're venturing into the realm of speculation and possibility. It's a question that has captivated a lot of people. Let's explore that a little further.
So finding naturally occurring wormholes is, well, probably not going to happen anytime soon.
Yeah, probably not.
But could we, make our own? Is that even something that's remotely possible scientifically?
Now that is where we get into some really speculative science.
Yeah.
Building a wormhole sounds like something out of Star Trek.
Right.
But there have actually been some theoretical proposals about how we might be able to do it.
Really? No way. What kind of ideas are we talking about here?
Well, one of the biggest challenges, like we've been saying, is exotic matter. We would need to figure out how to make and control this, well, hypothetical stuff.
Right. That stuff with negative energy density, it's unlike anything we've ever seen.
Yeah, exactly. It would require us to understand physics and engineering in ways we just don't right now.
I mean, what kind of technology could even do something like that?
Well, some physicists have suggested using super powerful electromagnetic fields or even manipulating space-time at the quantum level.
I mean, that sounds like something that's centuries away.
Wait.
Or like millennia away. But let's just say, hypothetically that we figured out exotic matter. What else would we need to think about to actually build a wormhole?
Well, even if we could create a wormhole, there's the problem of size. A lot of the models we've been talking about deal with microscopic wormholes. So scaling that up to a size that could fit a spaceship, that would be another huge hurdle.
So we'd have to figure out how to supersize them.
Pretty much, yeah.
And I imagine that would take a ton of energy.
Oh, yeah. Stabilizing a wormhole big enough for anything to travel through, that would probably take an insane amount of energy.
More than our entire planet uses.
Way more. We might even need to harness the power of stars.
Wow. It's amazing how exploring these ideas makes you realize what might be possible out there. I mean, even if we're hundreds of years away from being able to build a wormhole, just thinking about them is incredible.
I agree. And who knows, maybe someday these crazy ideas we're talking about will become reality.
Right. Someone listening to this could be the person who figures it all out. But even if we never figure out interstellar travel through wormholes, I think this has shown us something really important.
Oh, what's that?
How everything's connected in the universe.
Yeah.
We've been talking about gravity and black holes and wormholes and even quantum mechanics and information. It's like a giant cosmic tapestry where every thread is tied to all the others.
I couldn't have said it better myself.
Yeah.
And even if some of this stuff is still just theoretical, it shows us just how beautiful and complex the universe really is.
Well, I think that brings us to the end of our deep dive into wormholes.
It's been fun exploring these mind-blowing ideas with you.
And thanks to everyone out there for listening. We hope you've enjoyed our journey into the world of wormholes.
And keep looking up at the stars. You never know what mysteries are waiting to be discovered out there.